Okay, hello everyone. All right, so the next program in chapter 6 is temperature class. All right, I have a bit of a cold, so I'm going to sound a bit funny. All right, so write a temperature class that will hold a temperature in Fahrenheit and provide methods to get the temperature in Fahrenheit. Celsius, am I reading it right? Yeah. Write a temperature class that will hold a temperature in Fahrenheit and provide methods to get the temperature in Fahrenheit, Celsius, and Kelvin. The class should have the following field. Only one field called ftemp that is going to hold a double. Okay. So basically, yeah, it's going to be a double variable that's going to hold a Fahrenheit temperature, or basically a variable that's going to hold a double value, okay, of temperature. All right. So the class should have the following methods. Constructor. The constructor accepts a Fahrenheit temperature as a double and stores it in the ftemp field. setFahrenheit is going to be a mutator. Okay, that's going to accept a Fahrenheit temperature as a double and store it in the ftemp field. getFahrenheit is going to be an accessor, which is going to return the value of the ftemp field. It's ftemp field. That's all it's going to do. It's going to return the value of ftemp field as a Fahrenheit temperature. No conversion is required. So that's why there is no conversion required, because all it's doing is returning the value of the Fahrenheit ftemp field. Now, get Celsius is going to return the value of the ftemp field converted to a Celsius. And we know we have some formulas here, but we'll get to that in a second. Get Kelvin is going to return the value of the ftemp field converted to Kelvin. Now, get Celsius is returning the value of the ftemp field converted to Celsius. So the way we convert the ftemp field to a Celsius is using this formula. The ftemp field is going to, the value of the ftemp field is going to be here, and then we're going to get a result to Celsius. And this is the formula to also get the Kelvin. Okay, so now demonstrate the temperature class by writing a separate program that asks the user for a Fahrenheit temperature. The program should create an instance of the temperature class with the value entered by the user passed to the constructor. The program should then call the object methods to display the temperature in Celsius and Kelvin. Okay, so we are basically going to create a temperature class, which is going to, each object is going to basically represent a Fahrenheit temperature. You can think of it that way. But then it's going to have methods that is going to convert the ftemp field, okay, the value stored in the ftemp field, to Kelvin and then Celsius. So let's start. We're going to have two files. The first file is going to be the class itself, and the second file is going to be the program that is going to test the class. So this is going to be the file that's going to have the class. So let's start. I'm going to go ahead and create a class. So public class, I'm going to go ahead and call it temperature. Okay, temperature. Public because I want this class to be available to code outside of this class. Okay, so let's move on to the fields. Now we know we have only one field here called ftemp. So it's going to be a double that holds a Fahrenheit temperature. So I'm going to define it as a private, and I'll explain that in a second. Private double. I'm going to call it ftemp. Now, private because I don't want code outside of this class to be able to directly change the content of this ftemp variable, or to be able to directly see the content of this ftemp variable. I don't want any code outside of this class to be able to directly do that. I want it to use other means to see the content of this variable, or change the content of this variable, but I don't want it to be able to directly do that. So I'm hiding it from code that is outside of this class. They don't see it. The only way they can change it or see it is by using the public methods I'm about to define to either see or change the content of this ftemp variable. So you'll understand that more. But then that's what we are doing. We are basically hiding the data. We are hiding the field, making it hidden to code that is outside of this class. Any code outside of this class is going to be hidden. Any code outside of this class is going to basically not, this variable is going to be hidden, not the code outside of this class. So this variable is going to be hidden to any code that is outside of this class. All right. So yeah. Okay. All right. So now let's move on to the methods, okay? Basically the constructors, accessors, mutators. So the first one is going to be a constructor over here. The constructor is going to accept a Fahrenheit temperature as a double and stores it in the ftemp field. Okay, so now the constructor is just like a regular method, but then it does not have the keyword static. Okay, at the same time, it does not have, well, at least for this one, it's not going to have the keyword static. And at the same time, it's not going to have a return type. The reason it's not going to have a return type is because we don't call it ourselves. It's automatically called when you try to create an object from this class. And because we don't call it ourselves, because we don't explicitly call it, it cannot return a value. And because it cannot return a value, we don't specify a return type. So no static keyword, no return type. It's just public, basically the access modifier, which is going to be public because we want code outside of this class to be able to use this constructor to create an object from this class. So public, and then the name of the constructor. In this case, always the name of the constructor, actually the name of the constructor always has to be the same as the name of the class. So we called our class temperature. We are going to call our constructor temperature. So public temperature here. Again, it's going to be like a regular method except for the things I mentioned before. Now over here, the question says the constructor accepts the Fahrenheit temperature as a double and stores it in the ftemp field. So it's going to accept a double Fahrenheit temperature. I'm going to call it Fahrenheit given. Okay, and stores it in the ftemp field. So what it's going to do is it's going to change ftemp to the Fahrenheit given here. All right, so that's what this constructor is going to do. The next thing is going to be a mutator, okay, or a setter. Okay, this is going to set the value of the Fahrenheit field. Now the set Fahrenheit method, okay, is also going to be a regular method, right? So public, because I want code outside of this class to be able to use this method to set the Fahrenheit field of that object. It does not have the keyword static because it's an instance method, and instance methods are methods that work directly on the fields of an object that is created from this class. If any method is working directly on the field of an object created from this class, that method becomes an instance method. And with instance methods, you don't add the keyword static. Just for now, just know that instance methods, you don't add the keyword static. Later on in chapter 8, once we get to further in the book, we will learn more about it. But for now, just know that instance methods don't have the keyword static, right? So public, and then it has everything else. We have to specify the return type. So public, the return type for this one is going to be, let's see. Okay, so all it's doing is it's setting the value of it, right? It's going to set it from an old value to a new value. That's all it's doing. It's not returning anything. And when a method is not returning anything, we specify the return type to be void. So public void set Fahrenheit. Public void set Fahrenheit. And Fahrenheit is basically setting the old value of ftemp to a new value. And the new value is going to be an argument that is going to be passed into this method whenever it's called. So we have to go ahead and define a parameter for that argument that is going to be passed into this method. Now, if you look at the set Fahrenheit definition, it says the set Fahrenheit method accepts the Fahrenheit temperature as a double and stores it in the ftemp field. Okay, so it's going to accept over here as a double the ftemp. As a double the Fahrenheit temperature, and it's going to store it in the ftemp field. So I'm going to go ahead and define a double variable. I'm going to go ahead and call it Fahrenheit given. Again, Fahrenheit given. And what it's going to do is it's going to set the ftemp field again. So just like the constructor, you can think of it that way. No, but you can't. It's not the same thing. It's not the same thing. I'm saying that you can think of it that way because it's the same thing. It looks the same thing, but then they're not the same things. The constructor is doing something similar, but not exactly the same, but something very, very similar. Okay. So ftemp is going to be equal to Fahrenheit given. Doesn't matter if these names are the same. The scope of this Fahrenheit temperature, this Fahrenheit given variable is within this method. That's all. That's where the scope is. That's where it can be used. So these two are considered two different parameters. Okay. All right. So Fahrenheit given, ftemp over here. Let's see. Yeah. So ftemp is going to be equal to Fahrenheit given this way. Yeah. So that's what the mutator is going to do over here, set Fahrenheit. All right, so we have a get Fahrenheit, which is going to be an accessor or a getter, okay? An accessor or a getter. Now, the accessor is also basically, this method is also an instance method, because guess what? It's working directly on the ftemp field. It's getting the value of it. So it becomes an instance method, and instance methods don't have the keyword static, okay? But everything else. So public, because again, we want it to be public. When you think about it, when you call the get Fahrenheit method, what we want to do is we want it to return the value of the ftemp field, okay? And when you read the definition, it says returns the value of the ftemp field as a Fahrenheit temperature. No conversion is required. No formula is required. Just return the value of the ftemp field. So if it's returning the ftemp field, which we know is a double, so we have to specify the return type as a double over here. So public double, because that's the return type. We're going to call it get Fahrenheit here. Then we know that it's not accepting any arguments, because all it's doing is just getting the value stored in ftemp. So it's not going to accept any arguments. So once that method is called, all we want it to do is return ftemp. Okay. All right, so the next thing is going to be get Celsius. And get Celsius is going to return the value of the ftemp field converted to Celsius. We will need a formula for that, which has been given to us here. So let's go ahead and create that method. So that's also going to be a regular method over here. I'm going to go ahead and call it, it's going to be a public. Okay, so also we have to specify the return type. The Celsius, get Celsius, okay, that value can be a double, right? So let's go ahead and define the return type to be a double. So public double, get Celsius. And get Celsius is basically not accepting any argument. All it's doing, okay, it's not accepting any argument. So all it's doing is returning the result of the it's returning this Fahrenheit temperature converted to Celsius, right? We've been given a formula here. Now you would think that we should define a field here called Celsius, and then set Celsius over here to the result of this calculation. But then when you do that, you can end up having stale data, right? So if you do that, if you store a Celsius variable, you store the result of the calculation in here. Now what happens is, when the field ftemp field changes, then the result stored in that variable, okay, is no longer accurate. It's no longer accurate. It's no longer correct. So it's not a good idea to do that, because you can have stale data. Rather, what we should do is go ahead and just directly return the result of the calculation without storing it in any variable. Just return it directly. Return the result fresh, okay, directly, so we don't have the problem of stale data, right? So return this calculation basically, right? So let's just return 5 times 9. Oh, sorry, 5 divided by 9 this way. But then with just this 5 divided by 9, there's a problem. Right, so 5 divided by 9 over here, there's a problem. So let's deal with that. I'm putting parentheses because I'm just writing it the same way. So 5 divided by 9. 5 divided by 9, this is an integer, this is an integer. Now when you put 5 divided by 9 into a calculator, let me just pop that really quickly. Now you'd expect to get a decimal, right? Because this is not even. This is not even division. It's not evenly divisible, right? So 5 divided by 9, you're supposed to get a decimal of 0.555, right? But then this calculation over here, it's not going to result in 0.555 because Java is going to consider this as an integer division. Okay, because this 5 is an integer and this 9, both operands are integers. When both operands are integers, even when you're supposed to get a decimal as a result, a decimal as a result, because both operands are integers, Java is going to return not 0.55. It's only going to return the integer portion of this result. It's going to return 0, and that's a problem because if we leave it this way, our answer here is going to be 0. Right? The only way that you're going to get 0.55 out of this result is one of these values has to be a double. One of these values, it has to be a double. Right? If this was, let's say, 5.0, you're fine. One of these values has to be at least, right? So if both of them are doubles, that's fine, but at least one of them has to be double, either the 5 or the 9. We can try to fix that with typecasting. Okay, we can cast one of these values into a double, right? So for now, I'm just going to cast the 5 into a double. So I'm going to type the word double in front of 5 in parentheses. So double in parentheses and another 5. Double in front of 5 in parentheses, and that is going to basically cast 5 into a double. Okay, so now let's move on. So times Fahrenheit, which is Fahrenheit refers to our ftemp field. Okay, so times in parentheses, all right, over here, ftemp, okay, minus 32. So that's the formula we want basically. So anytime we call the get Celsius, just basically return this, right? So that's our get Celsius method, right? So let's go ahead and create our get Kelvin method also. It's going to be public get Kelvin here. And it's also going to be a regular instance method. Oops, what did I just do? I didn't specify the return type. Okay, so it's also going to return a double because the Kelvin temperature can be a double, right? So it can be 28.6 or something. So let's go ahead and specify the return type to also be a double. And then it's not going to accept any arguments. It's just going to return the result of a calculation. So just go ahead again, because we don't want the problem of stale data, just go ahead and return the formula, or basically the calculation, which is for Kelvin is 5. So basically we have a couple of parentheses here. So let's just follow the same format. So we have an outside parentheses for all of these. That's where everything goes. And we have 5 divided by 9 in its own parentheses. But again, we know that this is a problem, so we have to typecast one of these. Now for this one, I'm just going to typecast 9 just to show you that at least one of them, it can be any of them. Okay, so I'm just going to typecast a 9, type in double in front of all of them, just do this, parentheses, and double goes into it. Space, just to make this clear. I like to put spaces, in between these characters just to make it clear and easily visible. Okay, so we're here, and then now we have to go ahead and multiply this by another parentheses, the ftemp minus 32 here, and after all that we add 273. So that's the formula we've created here. So when we call get Celsius, return this. When we call get Kelvin, return this value, okay, based on value of ftemp. All right, so now we're done with the class itself. We have created the constructor, which is over here. We've created the one setter, one accessor, or basically one mutator, one accessor. We've created 2 methods. So we're good. I like to have my constructors below as the last thing in the class, so I'll just cut it and paste it there. I sometimes have it up there too, but most times I have it there because that's when I was learning it. This was the first thing well in the book it starts. I think it starts. It's mixed, but for the most part I think it starts. But when I was learning this in class, the first thing that professor did was put the constructor below, and I like that professor, so I just got used to it. I just got stuck with it. But if you put it anywhere, it should work. That's funny. But I mix it up. Sometimes I put it here, sometimes I put it here. That doesn't make a difference, but let's just put it here for now. All right. So now we're done with the class itself. Now, when you think about it, this is just a regular class. It's not a program. It's not a complete program. So when you try to run this, it can't. because it doesn't have a main method. It's just a class, okay, a class that another program can use. So we can't really run it, but you can compile it, right? And then, so let's go ahead. This is the previous program. Let's save it in chapter 6, create a new folder for temperature, temperature class, and save it here as temperature.java. Okay, so we compiled that without any error, so that's fine. Now I'm going to save this again. This is just a class. I'm saving this in a folder, right? And I'm going to create another file that is going to test this class. As long as both files are in the same folder, they should be able to see each other and then work with each other, right? But if you don't have it in the same folder, that's where you have to specify the path of the other one that is not there, right? So I'm going to go ahead and create a program that is going to test this, because when you think about it, the question over here is set. Now let me go ahead and copy the question and paste it in the new file as well. So do that, and then come to the new file and then paste it, so we can refer to it. Take this down a bit. Okay,